let me to use interface ETH00, then IP access group, for example, A inbound direction. Now, show IP interface ETH00 can show us that here we have inbound access list and the name of this ACL is A. So easy. Now let me to verify it from the PC1. Okay, before apply this ACL, we had connectivity to the PC2, to the PC3, and to the PC4. Now, ping 10.0.0.2. As you can see, as you know, we don't expect to have connectivity. Look at here, we don't have connectivity. And here in the switch, show IP access list A, okay, as you can see, is available, but here we don't have any match. Why? Because this statement, the statement 10, doesn't match any traffic. And then PC, let me to send traffic from PC1 to the PC3, ping 10.0.0.3. As you can see, we have connectivity. And then in the switch, as you can see, show IP access list A can show us that we have 5 match. It is working, so easy. Then again from the PC1, let me to send traffic to the PC4, ping.10.0.0.4. As you can see, we don't have connectivity. It is obvious. Don't forget, now we have connectivity from PC1 to PC3. Okay, let me to show you what happened when we send traffic from PC3 to PC1. Look at here, from the PC3, ping 10.0.0.1. As you can see, we have connectivity. Why? Because actually this ACL doesn't check the outgoing traffic, only incoming traffic. Because of that, the traffic from PC3 now goes to the ETH00. Here we don't have any ACL. Because of that, traffic will accept, and after that traffic should forward it to the ETH00 and the answer received from the PC1. But if you send traffic from PC2 and PC4, this traffic will receive by PC1, but when PC1 answer to the switch doesn't allow the traffic pass to the PC2 and PC4. Now let me to configure the next ACL for communication between the PC2 and PC4. It is so easy. This is our notepad file. Okay, here in the switch I want to configure the next ACL. This is the next ACL, for example ACL B. Okay, IP access list extended B, and then permit IP host from the 10.0.0.2 to 10.0.0.4. And after that, let me to apply it to the ETH01. Okay, interface ETH01 IP access group B in. You can configure MAC ACL or a standard ACL. All of them are supported. Here, let me to show you in the switch. First, configure terminal, IP access list extended B, permit IP host, okay, from the 10.0.0.2 to the host 10.0.0.4. And then interface ETH01 IP access group B, and then inbound direction. Show IP access, show IP interface ETH01. Here the inbound ACL is B, so easy. Because of that, PC2 now can send traffic to the PC4 only, ping 10.0.0.4. We have connectivity, but we don't have connectivity to the PC3. Now look at here, ping 10.0.0.3. We don't have connectivity, but you know that because we didn't configure any policy, any ACL on the ETH02 and also on the ETH03, PC3 and PC4 now have connectivity. Let me to show you PC3 ping and then 10.0.0.4. So easy. Actually, we can say port ACL are similar to router ACL, but are supported on physical interface and configured on layer 2 interface on a switch, okay? And port ACL support only inbound traffic filtering, okay? Port ACL can be configured as 3 type access list: a standard, extended, and MAC-based ACL. Here you can see the commands. If you want, you can configure the MAC ACL or IP ACL, IP access group. This is the command that you should use to apply the MAC ACL to, or the IP ACL to the interface. IP, look at here, IP access group name or number, or MAC access group name or number. But don't forget, here we should use only inbound direction, not inbound and outbound. It is so important. Show IP access list or show MAC access group are two commands that we can use for verify the PACL. About the PACL, we should know about some notes. Let me to explain them. First, about the command IP MAC access group name or number. This is the command, and also only we can apply it in inbound direction. And also about the port ACL, let me to emphasize some notes. First, PACL only support filtering incoming traffic on an interface, no outbound filtering support. I explained it, okay? After that, port ACL cannot filter layer 2 control packets such as CDP, VTP, DTP, PAGP, UDLD, and STP. It is obvious. Only we have control with ACL on user data, not on control traffic. After that, PACL are supported only in hardware, and then PACL do not support ACLs to filter IPv6, ARP, or MPLS multi-protocol label switching, and it means that you can use PACL only for control over the user interface, user traffic, not the, for example, control packet traffics. Also, about the PACL, the CLI syntax for configuring PACLs that are used to filter layer 3 traffic is the same as the syntax for RACL on any iOS router. The only difference is that PACL also support layer 2 MAC address based filtering, which uses different CLI syntax, and PACL can be standard, extended, or named IPv4 ACL for layer 3, and they can be named MAC address ACL for layer 2 traffic.